Hello everyone, welcome to this video tutorial on generators and iterators in Python by Simplilearn. And do subscribe to our channel and click on the bell icon for more updates.
Now, what is a generator in Python? Python generators lets you create your own iterative functions that return the traversal object with a sequence of values. So basically, when with iterators, you can only work on list, tuples, or sets, but with generators, you can convert your functions into iterative functions itself. And we will see that when we will be working on a Jupyter notebook. Now, another important feature in a generator function is that a yield statement is used rather than a return statement. So basically, the return statement terminates a function entirely if you use it within the function and basically return from the statement, while the yield statement pauses the function there it is and holding all its states, all its variables, the values in the variables, and then continue thereafter on the successive calls. So basically, in a generator function, you use yield functions, and I will talk about the utility of this yield statement within the generator function, how it helps in generating pipeline. But just to hold a thought over here and understand the concept, the yield statement basically holds the processing of the function at that point. And if you make an invocation of that generator function again, it starts from there itself where you left it. As compared to return statement, return is a general exit. If you make an invocation of the return statement from a function, it will restart again from the beginning if you invoke it the next time, and that's the basic difference. So what are the advantages of using generators? It's very easy to implement. The code syntactically it's very simple. Within the few line of codes you are able to achieve the functions and able to implement the logic. You can generate infinite sequence. You don't need to provide the range values, the starting and ending. You can generate an infinite value, and I'll show you that with an example. And generators are very memory efficient. They are the most memory efficient ways of processing huge data sets. They process the data incrementally and do not allocate memory to all the results at the same time. They do that incrementally. They really come in handy when implementing data science pipelines for huge data sets in a resource constrained environment where you have constraint on the RAM and the other resources of the hardware. Now, another biggest advantage is pipelining with generators. Generator pipelines are a great way to break apart complex processing into smaller pieces when processing list of items. So basically you can break your complex code into smaller pieces and then invoke them as a generator recursively, and we will see that how. But basically, you are making the complex code look simple and making it invoke in a pipeline fashion. Now, the another most important function in order to deal and operate with the generator is the next function. The next function is used to retrieve elements from a generator object and then print it. So that's how you basically interact with your generate function. You cannot do that until unless you don't use next function. So now let's quickly jump to our examples which we are going to support for each of these concepts. Now let's start by basically creating our first generator function. I'm going to create a variable n and initialize it with 1, and I'm going to do a print. This is just for my logging and showing on the console that where we have reached, and then I'm going to say yield n. Okay, so now here we are not exiting the function. We are just saying that just this is the point. If you invoke the function again, the function will start from this point on. Now here you will increment, and again this is the second checkpoint in the code. And similarly, we're gonna have a last checkpoint in the code. Now, in order to create my generator, now this is the my generator initialization, my gen. Now, if I use the next function and invoke my generator, now my generator has been executed till this point, right? N equal to 1. Now, if I make a second invocation, now it has moved ahead and printed the second. So it is behaving like a loop. It is now behaving like a loop. It is behaving like an iterator. But I have not created any list. I have not created any tuple, but I am basically traversing through the variables, through the sequence of the variables within my generator. And if I again print it, this is my last, this is printed at the last. So all the checkpoints within my generator have been executed. Now the same example which I have over here, let me call it in a loop. Okay, so what I'm going to do is I'm going to remove these invocations and just replace it with a loop call, right? So this generator functions remain as is. Now, instead of writing my next function 3 times, I am going to just invoke my generator in the for loop, and this will get invoked the number of times I have yield in my generator, and my output should be the these logs which I have created, and of course the variables. Yeah, so see now what has happened is now the output is all these 3 print commands have been executed, plus the variable values of n has been printed at each checkpoint 1, 2 and 3. So when I initialize my item variable during the for loop, this item consists of the variable values which are there in my generator. Now I'm going to show you example of if I use a return statement in my generator. So I'm gonna create another generator and provide a value. Now in during this, in middle of this generator, I'm just invoking return, and then I am printing my second checkpoint and then the last checkpoint. Now I'm going to initialize my generator. Now if I invoke my first element of the generator, I'll get it. There's no problem because I printed the first item, I got the value of my yield, and then I returned. But now if I invoke my second element in the generator, but before invoking second, I have already given the return statement, my generator will exit and I'll get the stop iteration error. Now this is a Python generated exception which is denoting that you cannot move beyond the first item because you have returned from the generator over here. So that's the difference. If you just remove this, comment this out and then run it, you will get your second item. So it's not the code exits if you write return over here. So I hope you're able to understand the difference. Now let's take another example. Now here we are going to create a list, and how implicit list, like the way legacy way we have been creating in Python, differentiates like the way we are creating a generator. So what I'm doing is I'm creating a list with random numbers, and then another list in which I'm just square rooting the numbers in that list. And similarly, I'm also creating a generator which I'm expecting the same output in the new list as the generator, but I'm going to show you different ways of traversing the generator as compared to a list. Now, if you see this list underscore, if I just make a print call to this list, it's going to straightforwardly square root the numbers and give me the output 4, 9, 64, and 100. But if I print the generator, I will not get the expected output, what I'm expecting. I will just get the generator object, which is not what I desire. So basically, you can't just print the generator like the list. You have to either use the next, or you have to use the for loop, which I had shown earlier, and print each and every item within the generator. Now, this is the output which I was expecting. I was expecting the line by line output of each and every element in my generator: 4, 9, 64, and 100. Okay. Now, this for loop is taking care that it is not exceeding the number of items, the length of the items in the generator. So, this is automatically taken care by this syntax. But if you don't take care of it, then you will get an exception. Let me show you another example. If I create a list and now I'm creating a generator, which is square of all my elements. So now one by one, instead of the loop, I'm one by one printing the output. Second output, third element output, fourth element output. Okay, I have 4. Now if I try to again print, I'm exceeding the length of the list, I'm going to get an exception, stop iteration exception, because I'm exceeding the length, right? Either I use the for, or if I'm using individual print and next function, then I have to take care that, okay, how many elements are there in the list, and I cannot exceed beyond that, else the Python will raise an exception. Okay. Now I'll show another example of highlighting the difference between next and the for loop printing. I'm going to create a generator for 2 to the power n. So I'm initializing n with 0 and then just raising it 2 to the power n. Now here I'm initializing my generator and printing it. And I'm getting the expected output as 2 raised to the power 0, 1. Okay. Now another way of doing this job is I loop over this and I get the same output. So if you see, it's only, I do not have only one element. So either you use for loop or you print using next, the output is going to be same. Now, another important concept which I talked about, if you want to print infinite numbers, so, or you want to do some infinite calculations, I'm going to use print in all even numbers. So I'm going to write a generator which is going to print infinite number of even numbers. So I have created a generator and now I'm going to invoke this, and mind you, I have to kill this job because it's going to keep running. It's going to keep running because it's constantly generating the numbers, even numbers. So I would have to stop this. But if you see, otherwise this is not possible. In any for loop, the basic for loop, you have to give a range, start and end of the length. But using a generator, you can do infinite looping, right? Because here I had to kill this job, I have to do a keyboard interrupt. Now I'm going to show you an example of how you can use generators for creating a pipeline. So I'm going to take example of Fibonacci series, create an example of Fibonacci, two variables initialized with 0 and 1. And now I'm going to write the logic of Fibonacci, adding the two numbers to itself subsequently. And I'm going to add yield. Now this is my generator. This is my one generator. And I'm going to create second generator of square. So I'm going to show you in Excel what logic I'm going to apply and what will be my expected output. So I am now squaring the numbers which I'll get out as an output of Fibonacci. Okay. Now I'm creating a pipeline like this. First, I'm gonna generate Fibonacci series for the first 10 numbers. Then I'm going to find the square of each of the Fibonacci numbers and add it. So if you see this representation in Excel, I'm going to generate, these are the two variables which I've already initialized X and Y. And from here on, these 10 are my first 10 Fibonacci numbers. I'm going to calculate the square of these numbers, 1, 4, 9, 25, and till 55, the square of 3025, and then add these numbers and I should get the output of 4895. So if you see, one function generator, second generator, and the third calculation. Now this whole has been done in one single line of code. You have created two generators and just invoked them in a single line pipeline. So entire looping, and you don't have to write the looping operators, the for loop, and you don't have to worry about writing all that complex logic. It is all encapsulated within this. Now let me run and I'm going to expect this output 4895, and here is my output, right? So in the hindsight, what Python has done is it has generated these Fibonacci numbers, found the square of these numbers, and then added it in single line. And now this is the convenience, simplicity which I was talking about earlier. Now let's take another example of Fibonacci. I'm going to create a generator again, initializing A and B with 0, 1. And this time I'm taking an example of printing the Fibonacci in two different ways. Okay, I'm going to print the first 5 Fibonacci series number. The first way I'm going to do is I'm going to print the next function 5 times because I'm generating 5. So let me run this. These are the first 5 Fibonacci numbers, 0, 1, 1, 2, and 3. And I'm also going to use a loop in order to print. So now in the loop, I'm invoking the 5 Fibonacci numbers and run it. So either you can make 5 individual calls, or you can use the for loop, but the output is the same and you're using a generator. Now, what is a Python iterator? Python iterator is an object that can traverse through iterable objects in Python like lists, tuples, dictionaries, sets, and returns data one element at a time. So basically you can traverse through these lists one at a time, and then you can use it as per your custom requirement. But iterator as an object is available to you, is a tool available to you in order to traverse through each and every element. Now, they are implemented within for loops, comprehensions, generators in Python implicitly. They are not visible upfront, but they are hidden in plain sight. So basically, when you're using loops, when you're using generators, comprehensions, implicitly Python is actually converting them in the backend in an iterator object and giving you the results. Now, what are iterables on which you can iterate? Lists, tuples, dictionaries, sets, as I mentioned, are all iterables or iterable objects. Other than these, you can't perform any iteration. If you have not created an object of list, tuple, or dictionary or set, then of course your iterable will not be of any use. And these objects internally possess an iter method, iter method, which is used to get an iterator, a handle to an iterator, and then you can start looping it, or you can start accessing the elements of the iterator. Now, how iterator works? Python iterator implements internally these two methods which you are seeing on the screen, underscore underscore iter underscore underscore brackets and underscore underscore next underscore underscore brackets. Now these two methods are implicitly implemented by Python for any internal implicit iterator object. But if you have to write your own custom iterator, then you need to override these methods, and I'll show you in my examples in Jupyter Notebook. The iterator object is initialized using the iter method. So basically, whenever you have to create an iterator object, you need to initialize it with iter and then use next method in order to traverse through it. Now, stop iteration exception. So as I mentioned, when we reach the end of an iterable, right? Like suppose you have a list or a set which has a length of 4. When you have ended the fourth element and you're trying to access something beyond fourth element, which is fifth, then of course you can implicitly raise a stop iteration exception or Python will throw it. So we will see that with an example, but you will get a stop iteration exception. No, so to prevent, in order to handle it or manage it in your code, we use stop iteration statement to raise an error. You can raise your custom error. So you can catch this exception and then raise your custom error in the underscore underscore next method. So now let's support everything with our examples. Let's start with a very basic example of an iterator. Now let me create a list with just 4 numbers, and as I said, I'm going to initialize my iterator with iter method. So now I have created a list and now I am initializing it with iter. Okay, now using next I'm going to print my first element 4. Okay, so it means the iter internally has given me handle to the first element, and now as many times I move print next, I am moving to the next element. So now I'm also going to show you a different syntax. This is a syntax, but the output will be same. It's a different syntax to invoke underscore next. So its output is going to be same, but the syntax is only the difference over here. So you're going to get access to the next element and then my fourth element, which is 33. Now I have traversed through all my 4 elements. Now what will happen if I again do next? I am at the end of my list. So I'll get an exception of stop iteration, right? And this is thrown by Python. Now let's take another interesting example. If I want to perform iteration on strings. So I have created a variable and I have initialized it with geeks. And now I have created an iterator on top of this string variable, and I'm going to traverse it till the time I reach the end of my string. So let me iterate it, and I'm going to iterate till the time I get the stop iteration exception. So also I'm explaining here how to cleanly handle the exception, accept, and then break. If I get the exception, I'll break out of this program. And here you get the result. All the letters of my string geeks has been printed individually. And I think it's a very important example, interesting example, that how a string has been converted. Now, point to be noted over here is that Python has internally invoked __iter and ___ next methods, which it has implicitly implemented for string iterators. So you don't need to do anything. Now let's take another example to how to traverse through a list using for loop. So I'm going to leave for object in list and just print the list. This is without an iterator. I'm just printing my list. So I'm just trying to show the difference that if you use an iterator or you do not, but how you can access the elements in the list. Now let's take an example of how I can write my own custom iterator. Okay, so I'm creating a class where I'm overriding the init method, basically initialization of my class, where I'm going to initialize a variable max with 0, and then I am overriding, this is the most important point over here, I am overriding iter method, and then I am writing another overriding the ___ next method, where I am adding 6 to my number and then incrementing my loop so that I can move further. So in this _ next method, I am just moving beyond adding 6 and till the time I reach the max variable. So when I'll invoke my class, I'm passing 9. So it means that I should not go beyond 10. Basically, I should start my iteration from 6 and will not go beyond 10. 9 plus 1. So I should get numbers which are between 6 to 10 as per my expectation. Now, before we diagnose the output, most important point is that how you have converted your class to an iterator over here. In order to make a class an iterator, it is mandatory you override iter and next methods, which you have done over here. So now let's print. Okay, so 6. So my number started with 0, initialized with 0, and I added 6 to it. So my first result is 6. And now if I keep printing, I will get one value incremented. 7, 8, 9, and 10, right? So this is the expected output, right? Now, another example on the same lines, I'm going to print the first 20 numbers using my iterator. So I am going to override the iter method and ___ next method, my numbers. Now in this ___ next method, I'm just incrementing my number by 1, not by 6, and I'm going to stop at the limit 20. So like I showed in my previous example, I'm going to initialize first my class and then initialize my iterator and just then gonna run a for loop on it. And here is the response output. I have printed the first 20 numbers because I have created this limit. So I am initializing with 1 and going till the max 20 number. But the point is, it's not the output which is more important over here. The most important concept over here is that you have created your own iterator and leveraged it. I hope you had a great learning session, and I look forward to meeting you in my next session. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.